Alright, we are getting into compound inequalities. Compound inequalities are situations that you can graph. Alright, it's formed by combining two or more simple statements. A compound statement can be true or false, and a lot of it has to do with whether you're using the word and. Alright, compound statement involving and is true when both statements are true. Or perhaps the word or. A compound statement involving the word or is true when either one is true. So if you come over here, right, is a dog a mammal? That is totally true. I'm going to say true. Is red a color? Totally true. Are they both true? P and Q, true or false? P and Q are both true, right? A dog is a mammal. That is true. Red is not a color, totally false. So are they both true? No, this one's true and this one's not, so we're going to say false, right? Dog is a fish. No. Red is a color. True. P and Q are both P and Q. Are they both true? False, right? A dog is a fish. False. Red is not a color. False and false. So only one of these met the requirements. P and Q is true when dog is mammal and red is color, or we could say both true. Alright, now this one's a little different. 1 is an odd number, totally true. 2 is an even number, totally true. P or Q. Well, I could go to either one, right? This is true or this is true. Well, they're both true, so I get a nice true. 1 is an odd number, true. 2 is an odd number, false. But you know what? P or Q. P is true, so I'm allowed to say true. 1 is an even number, totally false. 2 is an even number, totally true. But, you know, I only need one of these over here, so I'm going to say true. Q or P, but Q is there, so I don't need anything else. 1 is an even number, false. 2 is an odd number, false, and that one's false. Is when 1 is true. That's when this is true, when one of them is true. Give two examples, statements P and Q for which P and Q is false and P and Q is true. Alright, so let's just refer it up to here. Alright, two examples, P and Q is false. We're going to say 1 is even, 2 is odd. Alright, they're both true. We're going to refer this to here. 1 is odd. 2 is even. Alright. Now, let's go ahead and do one more page. That way we can get two done at once. Alright. Solving compound inequalities involving and. So we're going to hit the first one that has and. Remember, there's an and or an or. And if I get through the ands, which I think I can. Ooh, yeah, we'll get through the ands. Alright. Combining two or more simple inequalities forms a compound inequality. The graph of a compound inequality involving and is the intersection or overlapping region, right? So I could say this region right here is when x is greater than 2 and x is less than 6. I want to point out something, right? I want to point out these open circles, right? If I don't have an equal, it's an open circle. If I have an equal, like this next one, see those closed circles? It equals a closed circle. It just means it includes those. So if you look here, right, we have sketch a compound inequality and graph solutions. So we have 4x plus 2, all right, and x plus 4 is less than, let's look at it, there's part of it. This part right here is right here, 4 is less than x plus 2. And here's the other part, I'm going to put it on the top. Right, x plus 2 is less than or equal to 8. So if we solve those, you solve this just like you normally would subtract 2. You got 2 is less than or equal to x, and we subtract 2 over here, and x is less than or equal to 6. We can graph them both separately. See? Here is when x is greater than 2. Notice the hard circle because the equal sign, that filled in circle. And here's x is less than or equal to 6. Right? So if we're going to graph using the word and, all right, it has to be both. So it can only be the area in between them. Let's try this one. Ready? We're doing and. So here's our middle part. All right, this says 5 is less than or equal to 2x plus 3, all right, which is less than 9, and we can see it over here. So we're going to start by moving this 3 on both sides. So we're going to subtract 3 from the middle. That's subtracting 3 from here. We're going to subtract 3 from 9. We're going to come over here and subtract 3 from negative 5. Well, negative 5 minus 3 is negative 8. And 9 minus 3 is 6. And the 3 disappears in the middle. Look, there's 3 sections, right? 1, 2, 3. We subtracted 3 from each of those sections. Now we're going to divide them all by 2. So divide this by 2, this by 2, this by 2. And negative 8 divided by 2 is negative 4. 2x, just x, and 6 divided by 2 is 3. So what we have is this. We've got 2 different sections, 2 inequalities put together. We got x that is capable of being greater than 4, so negative 4 anyway. So if I use that number right here, I'm going to use a solid circle, right? And x would be everything greater than negative 4. All right. This one says x is less than 3. Notice the open circle, and it's everything less than that. But it's got to be both. So I can't use this section up here, nor can I use this section down here. It is only the overlapping sections because we use the word and. So it's everything equal to and greater than 4 up to 3, but not equal to 3. So it's everything in between those circles right there. I hope reasonably easy. There's a couple more here. Alright, explain why 2 is less than or equal to x, which is less than or equal to 6, can be considered the short method for writing the and, right, compound. We're going to make 2 statements. So we make one statement instead of 2. Alright, now we got a couple here. This one's almost solved, right? So we're going to solve the x in the middle by adding 3 to all of these sections right here, which gives me 1 is less than, the 3 goes away, x, which is less than 8. All open circles. So I go to 1, I do an open circle, I go to 8, open circle, and it's everything in the middle. Kind of easy, right? These and statements aren't too bad. Let's do this guy right here. Subtract 2, minus 2, minus 2, minus 2. I get negative 12 is less than 3x, which is less than or equal to 6. Divide by 3 all the way across. And I got negative 4 is less than x, which is less than or equal to 2. Notice this. Open circle at negative 4, closed circle at positive 2, and it's everything in between. There's our words. We got the ands. I'm going to pause this. This can be the first video. 8 minutes, not too bad.